Today's lesson is review. Radicals we did the first week of school. Have you done Pythagorean's theorem before?
Yeah.
Yes. Don't know when you worked with it last year for sure. Don't know if was that the first time you guys ever saw it?
No, we saw it in 8th grade.
Okay, so you did see it in middle school, then you worked a lot with it last year. Yes, in Math 1?
Yeah.
Okay, radicals and Pythagorean's theorem. Part 1, first part of this radical piece of the notes will be review. Number 1, square root of 24. Write it down. Do you guys remember how to do square root of 24? How to simplify that, not just plugging in your calculator and getting a decimal?
The thingy?
Oh, I got that.
6 times 4?
Good. The factor tree. Is that the thingy you're talking about?
Yeah.
Okay, he said 6 times 4. My last class said 12 and 2. Does it matter what numbers you use?
No.
No, in the end we'll end up with the same.
Could have just did 12 and 2 and the circle of 2.
That's fine. We're going to do 6 and 4 because you said it. What's 4?
2 times 2.
And then
Circle.
6.
And 3 times 2.
Okay, and those are all my prime factors. So I do 1, 2, 3 2's. 1, 2, 3. And how many 3's?
1.
And then when we square root, we take out the singles.
The
Pairs. Okay, so how many pairs do I have here? Just
2.
one.
A 1, I mean.
Right? And that 2 right there doesn't get included because he's not part of the pair. It's chunks of 2, not 3. Does this come out as 2 or 4?
2.
2. So the 2 comes out and the 2 times 3 stays in.
6.
Good job. 2 radical 6. And that there is your final answer. You guys remember this? Yes or no?
Yeah. Yes.
Okay.
I think I remember.
Number 2, 3 square root 128. 128's even, so I'm going to suggest you divide it by 2. 2 goes into 12 and 2 goes into 8. What does that become?
24. Oh.
Close. What is it? 64. Now, guys, I'm going to use the shortcut this time. When I first taught it to you, I showed you the shortcut, but I didn't always use it. What does 64 break? There's multiple things, but what would you suggest me using?
3 times 2.
Now, is 8 times 8 64?
Yeah.
Is 8 prime?
No.
Can I still break it down?
Yeah.
Should I?
No.
No. This is where, even though it's not prime, does anybody remember why I can stop and start taking things out? Because they are a what?
Double.
They're a pair. They're doubles already. So if that's a double, do I have to continue breaking down? No, that was the shortcut. Again, I didn't always use it then, but I think we've seen them enough now to say, hey, I don't have to keep breaking that down because that's going to come out as what?
8.
8. And what stays inside?
2.
2. So I'm left with 8 root 2. Does anybody want to see it the longer way where you break everything down?
Wait, did this still come out with the same answer?
Does it come out with the same answer? Let's check. Let's see. What is 8 break down to?
4.
4 and 2, and this 8 is also 4 and 2?
Mm-hmm.
And this 4 is 2 and 2, and this 4 is 2 and 2? Okay, how many 2's do I have here?
6.
6, 7?
Oh, yeah. 7.
1, 2, 3, 4, 5. Why am I writing that? Sorry, guys. What should I be writing? I know, too late. 1, 2, 3, 4, 5, 6, 7. All right, how many pairs do I have?
2.
1,
4,
2, 3.
6.
So 2 times 2 times 2. What's 2 times 2 times 2?
6.
2 times 2, be careful, is 4.
times
4
2
times 2 is
8.
8 root what?
2.
And is that the same answer?
Yeah.
Which way was faster?
The shorter way.
This way here, the shortcut.
Shouldn't it be 24 too? Because it started with the 3.
Say anything?
It'll be 24.
Yes, you
right?
caught it? Okay. So if you're taking the test and I got all caught up in the shortcut, why is it wrong?
You have to multiply the 8 times 3.
Good job. Good job. And so did I. And I have the answers in front of me, which is shameful. Okay, so what do? The 8 comes out, and 8 times 3 is?
24.
24 root 2. Thank you guys for catching that. Okay, number 3. Root 12 times root 24. When it's multiplication, you can multiply them together. Now, the only reason I suggest you multiply them together is to see if it's a perfect squared. For example, say that was a 12 and a 3. What's 12 times 3?
36.
And is 36 a perfect squared?
Oh, yeah.
Yeah, so it's good to multiply. We did it here. Is 288 a perfect squared? Is it? It's not. Now, when I break down, I could break it down to 12 and 24 because that's what I just used. Or I'm going to use 2, only because I can see that if I divide by 2, can anybody do that in their head? 2, 2, 2.
144.
Why do you think I chose 2? Because 144 is a what? Perfect square. What does it break down to? Now, is 12 prime? No, but why do I stop and use the shortcut?
Because there's already 2 of them.
Because there's 2 of them. You're right. So 2, 12, 12. There's a pair. What's coming out?
12.
12. What's staying in?
2.
So 12 root 2. All of this is review from the first week of school. Questions on 1, 2, or 3? Okay, this next set here is what you're going to see more of the rest of this unit. Number 4, root 18 squared. What does the squared mean? I'm going to write the base how many times? Twice. Do you have to know what 18 times 18 is?
No.
No, because if I write this as a single radical, it's kind of like our shortcut earlier. Is that a pair?
Yeah.
And what does it come out as?
18.
18. So, eventually, you want to get to the point where you don't have to show these middle steps. You stop and you say, hey, the square root and the square will always undo each other. 18 is the answer. Does that make sense? So, number 5, square root of 56 squared. Can anybody do that shortcut without any work?
Yeah, I already can do that.
What happens with the square root and the squared?
It just stays.
They undo. What are you left with?
56.
56. I'm going to show the work anyway. But if you're at the point where you don't need the work, then you can skip all this middle stuff. Root 56 times 56, the pair comes out as just 56. Okay, number 6, 3 root 5 in parentheses squared. This one's going to come up a lot in this class. Put your phones away, make sure you guys are paying attention. I'm going to write it twice. This one I am going to take my time on. 3 root 5 times 3 root 5. And we have done these before. Is multiplication commutative? Meaning, is A times B the same as B times A? Can I regroup?
Yeah.
3 times 3 times root 5 times root 5. Now, these don't have a radical, so you are going to multiply. What's 3 times 3?
6. 9.
9.
Shoot.
Times, these two have a radical without saying 25. Without writing 25, what's root 5 times root 5 when you have a pair?
5.
Root 25, which is 5. But do you have to say 25 or write 25 to know that? No, root 5 times root 5 is 5. The same thing here. Root 56 times root 56 is 56. Here you're left with 9 times 5, which is? Okay. Questions? Okay. Number 7. Square root of 49 over 16, and the radical's big over the whole fraction. When we have something like this, you treat it like the multiplication. You can, when you're multiplying, you can write it under one radical, and you can separate them. The same thing here. You can take the big radical and separate it like this. That is allowed, and it's mathematically correct. All right, is 49 a perfect squared?
Yes.
Yeah.
Is 16 a perfect squared?
Yeah.
All right, what's the square root of 49?
7.
Over,
4.
and that's it. Does 7 over 4 reduce?
No.
No.
I wish it does.
Evan? Okay, number 8. I'll put the word at the top in just a little bit. 1 divided by root 5. 1 divided by root 5. Okay. Now, why in the heck do I have this when there's nothing I can do? Root 5 is not a perfect square. No pairs come out. Why am I giving you this problem? Here's why. When you're working on math problems, especially in this unit, and you do all your work and this ends up being your final answer, and this is what you put down on your answer column, I have to mark it wrong. Does anybody know why?
No solution.
There's a solution. This is your solution, but if you write your solution like this, I would mark it wrong. Why is that? Does anybody know? Because what? There's something with the denominator. Because there's what in the denominator?
Oh, it's that. The whole thing is
There's a radical in the denominator. Have you guys done these before? I don't think so. I'm going to put here rationalize. That's what it's called. They'll say rationalize the denominator. When you rationalize, you're trying to get the radical out of the denominator. Hold on, Mrs. Torres. Okay. Ashley? Okay. So, can we have a radical in the denominator? No. Okay, so here is what we are going to do. We're going to multiply top and bottom by root 5. Write it down and then pencils down. I want you paying attention. Wait. The new packets are right there by the hole punch. All right. Everybody wrote it down? Pencils down, you're paying attention? Okay. What is 7 over 7 reduced to?
1.
What's 5 over 5?
1.
What's root 5 over root 5 reduced to?
Root 1.
Root 1, which is 1. Do you guys agree?
Yeah.
Okay. And you learned in elementary school what that was called. When you multiply by 1, does it change the value?
No.
It's called the something identity. Do you guys remember?
Identity.
Multiplicative identity. What does multiplicative identity mean? It means it's the number you multiply, multiplicative. It's the number you multiply that keeps this identity. So if I multiply by 1, am I changing its value?
No.
I can change the way it looks, but am I changing its value? No. Okay, let's see. Why, of all the radicals in the world, why do I pick root 5? Why not root 7 over root 7 or root 8 over root 8?
Hold on, what's the question?
Because it makes a perfect square.
Because it makes a perfect square. You are correct. Or it makes a pair. I'm going to write this as root 5. Do you guys agree that 1 times root 5 is root 5?
Yes.
What's root 5 times root 5?
5.
5. Now you can say root 25, but what's the square root of 25? 5. Because there is a pair. That's why of all the radicals in the world we pick root 5, because it gives us a pair. Please make sure you're writing this down. Let's try another one like that. Number 9, 2 or root 2 over root 7.
Oh, this is easy, Miss Tori.
Okay.
Wait.
Inverse. Root 7 over root 2.
We're not gonna reciprocal here. We're gonna do the same thing we do here, because where's the only problem here? The radical at the top or the radical at the bottom?
Bottom.
The bottom. So I'm going to multiply top and bottom by root what?
7.
Okay. I'm going to ask you guys, why root 7 over root 7? Because that is equivalent to what number? Root 1. And 1 is the multiplicative identity. Of all the radicals in the world, why did I pick root 7?
Because it's the
It gives you a
perfect
pair, a perfect squared. 7 times 7 is 49. What's the square root of 49? 7. And because these are both in the radical, you can multiply them. What's root 2 times root 7?
2.
Okay. Now, first thing you should do, I'm going to cover the 7. What does 14 break down into? Are they both prime?
Yeah.
So do you agree no pairs are coming out?
No.
You say you multiplied and got root 8
Root.
or root 12, you would have to break out your factor tree and take out the pairs. Root 14 is done. Okay, 14 and 7 reduce, but does root 14 over 7 reduce?
Nah.
No, why? Because this is a
Radical.
radical and this one is not.
Nah.
You guys see how that works? Okay, Number 10. 3 over root 11.
Are you ready for Christmas this song?
Happy Santa Claus.
You know I'm finna be singing up and down.
All right. Okay, so you're doing your work. This is your final answer. Would I mark it wrong if you left it like this?
Yes.
Yes, because it's no radical in the bottom. We have to rationalize.
You have to flip it?
We don't have to flip it. I'm going to call on
Isaac.
Ronnie.
No.
Can you tell me what to multiply top and bottom by?
11.
Okay, hold on. I only asked Ronnie. Ronnie, say it one more time. 11 like this.
Yeah.
What do I need on it? Radical 11? Root 11? Okay. Why root 11 over root 11? Because that's equivalent to what?
The rational. 1.
1, which is the multiplicative identity to multiply. It's the number you multiply that keeps its original identity.
Is that another word for it?
Yes. Well, that's another word for 1. 1 is the multiplicative identity. Of all the radicals in the world, why did I pick 11?
Because it's the bottom one.
Because it gives you a pair, which gives you a perfect squared. Without knowing what 11 times 11 is, what's root 11 times root 11? 11.
11.
Just 11, right? Because it's a pair.
I was about to say 1,000 or something.
Nope, you don't need to know what the product is. Okay, can I multiply these two together and get 33?
Nah.
No.
It's 3 squared 11.
3 square root 11 because
It's something light.
this is a radical, this one is not. Now, can I reduce these two guys here, the two 11s?
No.
No, that's a radical, that is not. And these two I could reduce if they were reducible, and they're not. That is your final answer. Questions?
No.
Okay, we're going to move on. Part 2, Pythagorean's theorem. Shh.
Yeah, come on now.
Pythagorean theorem.
It's a blank.
All right, guys.
Come on, Isaac.
Okay. Pythagorean's theorem is a theorem that can only be used on what type of special triangles?
Right triangle.
On right triangles, and right triangles only. A, B, C. And what's the Pythagorean's theorem?
A squared plus B squared equals C squared.
Now you do have to remember when you use this formula, A and B are your legs, and C is always the what? Hypotenuse. They may not use A, B, and C. They might have different letters or X and numbers. Hypotenuse is always your equal C squared part.
Yeah,
All right.
That way.
Find the missing side.
Wait, how do we find a missing sign?
I'm going to show
later.
you. Well, we're going to have some with numbers.
Oh, okay.
So not up here, down here. Find the missing side, parentheses, radical form. Meaning I don't want you to plug it in your calculator and get a
You
decimal.
want us to do the what's it called?
Yes.
Marking?
Okay, number 1, we're going to draw this right triangle.
Oh no.
This is 6, this is 4, and this is X.
My triangle's not right. Triangle.
All right, when I do this, A squared plus B squared equals C squared. Where you put the C is the most important part. What is C? The 6, the 4, or the X?
The X.
Now, is it the X because C will always be the variable?
Nah.
No. But C will always be the
What's it called? The equal.
the slant, which is called the what?
The slope.
Hypotenuse.
Free.
The hypotenuse piece. All right, so what am I going to have? 6 squared plus X squared or plus 4 squared?
I thought it's
4
A squared
squared.
plus B squared.
This is your A. The A and the B are your two legs. And instead of A and B, I'm going to put 6 and 4.
Is it 4A?
It doesn't matter because I'm adding. So if you do 4 squared plus 6 squared, is that okay?
Nah.
Is it okay?
Yeah.
Yes, addition is commutative. Equals, and instead of C, what letter do I have?
X squared.
X squared. All right, what's 6 squared?
36.
Plus
16.
equals X squared. I heard somebody added. What is it? 52. And then, you guys have done this before. What do you do to both sides to get X by itself? Square root.
It.
Square root. And what happens with the square root and the squared? We've talked about that before. They undo each other. They're inverse functions, actually. You'll learn more about that next year.
That's something light.
X equals root 52. What do I have to do to the 52? Break it down? Does 2 divide into 52?
No.
2 and 26 is correct, and then that's still even.
Root 74.
What is it? All right, so I'm going to put it over here. X equals the square root of, what is it, 2, 2, 13?
Yes.
What comes out? The 2, as 2 or 4? So that leaves me with 13 root 2 or 2 root 13? 2 root 13. Okay. Number 2.
Remember those. Is this the last one?
Nope.
We got one more?
After this one, yes.
Say less.
Okay. 3x and root 15. 3x and root 15. Okay, and I forgot to label the hypotenuse. I'm sorry, the right angle. Okay. Again, most important piece is where your C is. Is it okay to say this is my C because the C is always X?
No.
No. It is okay to say the C is always the
Hypotenuse.
hypotenuse. And which one's the hypotenuse here?
Root 74.
The root 15 is your hypotenuse. It's opposite the 90. It's the longest side. Okay. A squared plus B squared equals C squared. Or could you do this as A and that is B? Does it matter? Does it matter?
No.
No. So I'm going to write it down. 3 squared plus x squared equals what squared?
15 squared.
15 or root 15? Root 15 squared. Okay, what's 3 squared?
9.
Plus x squared is just x squared. Now, without having to do any extra work, without writing it extra, yes,
It's 15.
it's 15. Good job. You already knew what I was going to ask. The squared and the square root undo each other. Do you guys agree with that every single time? Yes, so I'm left with just 15. Who knows what the next step would be? Yes. Subtract 9 to the other side. That gives me x squared equals, and that is 6. And then what do I do to both sides? Now remembering, when you square root a squared, what happens with the square root and the squared?
There.
They undo each other. They're inverse functions. X equals root 6. What does 6 break down to?
3 and 2.
He said 3 and 2. Are 3 and 2 both prime?
No.
Yes.
Are any pairs coming out?
No.
No, so we're done. X equals what?
6.
74.
The square root of 6. It doesn't, no pairs come out. It doesn't simplify further. Okay, questions?
You.
Okay, number 3. Is the following a right triangle? Now, how do we test if something is a right triangle? Do not look and say, oh, it looks like a right triangle, and I'm going to erase that. That should not be there because I know. That will not be there on these problems. I just got carried away. Okay, so when the right angle's not in that corner, can we look at it and say, oh, it looks like a right angle?
No.
No. We cannot look and say, oh, it looks like a right triangle, it must be. Because this angle could be 89 degrees, and 89 degrees, when you look at, does look a lot like a 90 degree. I do need you guys listening. What always works when it is a right triangle? Pythagorean's theorem. I heard you guys say the a squared plus b squared equals c squared. We're going to write that down. We're going to put down here, you're going to test by using Pythagorean's theorem.
Pythagorean's theorem. It's crazy.
Okay, so how do we test if something is a right triangle? And this question will be on the test. Can these numbers be the side lengths of a right triangle? What's the test we use?
Pythagorean.
A squared plus B squared equals C squared, where C is always the hypotenuse, which is the longest side. Do you guys know what side is longest? 9, or square root of 181?
Square root of 181.
This is your longest. So I'm going to do A squared plus B squared equals C squared. If it does work and they do come out to be equal, would you say it is or is not a right triangle? It is. What if it does not equal?
It's not.
Then it's not. So 9 squared plus 9 squared equals the square root of 181 squared. Everybody see that? Okay. What's 9 squared?
81.
81 plus 81. Without multiplying, without any extra work, what happens with the square root and the squared?
Cancels out.
Cancels out. 181. What is 81 plus 81?
162.
And does that equal 181?
Yeah.
No, it does not.
No, it does not. Definitely not. So can this triangle be a right triangle?
Nah.
No. So what's the answer? Not
Not
a
a Pythagorean.
right triangle.
Pythagorean. Yeah.
Not a right triangle. Any questions?
No. Red.